Welcome, friends, to this series of learning containers and Kubernetes. So, in the earlier couple of lectures, we saw how we can build a Kubernetes cluster on virtual machine instances on EC2. Even we saw how we can create the managed Kubernetes clusters like Amazon Kubernetes Services, Amazon EKS. Also, we saw how we can run our application on Red Hat OpenShift. We deployed the application on managed services, managed container services like Google Cloud Run, like Azure Container Services. So in this particular lecture, we are going to see how we can deploy the Kubernetes cluster on Google Cloud Platform, and this time we will use Google Kubernetes Service, which is GKE or Google Kubernetes Engine, and we will see how we can deploy the application on Kubernetes clusters like GKE in subsequent videos. Also, going forward, we'll learn how we can use Prometheus and Grafana and other monitoring tools, how we can visualize the operations and the application health inside the Kubernetes cluster. So let's get started. If you have missed the earlier lectures, we are highly recommending you to go back and watch those videos for having the different flavors of containers and Kubernetes engine, and also they will help you to learn the GKE more easily. So friends, this is our Google Cloud platform, and we are right now on Google Cloud dashboard. Over there in the left-hand side, you can see the Kubernetes engine is there, and maybe we can go to the overview page. First and foremost thing that it will ask to enable the Kubernetes engine API. So let's enable these API to get started with Kubernetes. And you can see in the overview, it is saying the builds and manages container-based application powered by the open source Kubernetes technology. So this is what Google actually started to build the Kubernetes on their own applications, and then it actually opened to the open source community, and from then onwards, this Kubernetes actually born into Google's internal projects, and then it went into the market through open source platforms. All right, so that was brief history of Kubernetes, how Google gave the birth of this marvelous topic. Now, in this particular page, you can see that we are having some overview and a couple of options inside the left-hand panel. And right now, we are having no clusters inside the GKE. So the first and foremost thing, we will go to these clusters and create one cluster. Now, I will come to each of these things one by one. So maybe you can get confused with leads and other stuff. But slowly we will go deep inside all these features of Kubernetes cluster inside the Google Cloud Platform. So right now we will create a simple Kubernetes cluster, and we will see how we can how we can use that Kubernetes cluster in a very easy way to manage the containers. So let's create the Kubernetes cluster by clicking this create button. And now what Google is recommending to use their autopilot cluster. Now, this autopilot cluster is, as the name specified, it automatically deploy your workload, and it will automate the node provisioning, scaling, and the maintenance. And you no need to worry about anything. It will automatically manage the workload and scale it accordingly. It will automate the node provisioning and all those stuff. Uh, and I really don't want to create our autopilot cluster because you have less control from your side. So when you are having most of the things under your control, like what are the actual VM instances is going to be created under the hood, we should have some um, control over there. We can create our own node pool. I think the flexibility will be there if you are having the control on all of these items. So that's why let us switch to standard cluster, but definitely autopilot is the recommended one, and Google recommends you to create your cluster on the autopilot one so that you can little bit of worry free about this cluster management. But if you are having your own resources or skills to manage the uh, clusters, this standard cluster will be helpful, and you can have the cost saving approach over there as well because it is having the great control over the managed one. So let's switch to standard cluster. And here it is saying that autopilot clusters are optimized for most production workloads and implement many Kubernetes best practices for security, scalability, and cost optimization. And Google recommends that autopilot clusters for most workloads. On the other hand, in standard clusters, Google manages your control plane where you can manage more configuration settings in your clusters and nodes. The pre-configured autopilot hardening measures or the default cluster configuration don't fit your use case. Standard cluster might be right for you. So this is a wise decision you need to take whether you need to go with the standard cluster or the autopilot cluster. In the standard cluster, in a nutshell, you need to control your configuration and you no need to worry about how Google is going to scale, auto scale, and implement the security for the autopilot mode. So for now, let's switch to standard cluster. And once this standard cluster form will be there, you can see these form where you need to provide some cluster name. So you can say my GKE cluster, and we are going to have all these things one by one. So bear with me. It may be a longer video, but it will be greatly helpful for you to create the GKE cluster so that your cluster will be great one to have the production level workload. All right. So this is our GKE cluster. Now, here you need to specify the location type. So either your cluster, control plane, and nodes are located in a regional or zonal one. So if you specify zonal, all your nodes will be created and along with the cluster's control plane in a specific zone. Now, you can specify the default node locations and you need to specify all these zones under this US Central 1C, uh, which is the zone you are actually specifying for your control plane zone. But apart from the control plane, your nodes will be distributed in different zones as well along with the control plane. So it may be 1A, B, or F, whatever is there inside the zone. And if it is regional, then you have to specify the region where your control plane, the other nodes are going to be located. Now, if you specify US Central 1C, basically it is going to be a zonal one because it is not going to be spread across other zones inside US Central 1. So maybe you can select more than one zone, for example. So for now, I'm fine with the zonal one, and maybe we can specify that our um, control plane will be created on US Central 1C, or maybe we can keep it as control plane to be created on Central 1A, and maybe our nodes in the nodes pool can be created in B, C, and A. So this is how I'm going to configure. It's a zonal configuration I'm going to set up, but that's absolutely fine for your use case. Uh, so just to note that any traffic between these zones are completely free. The target release channel you need to specify, and this is how that you are going to select a release channel for GKE to pick the version for your cluster uh, with your chosen balance between features availability and stability. So based on your target release, your version will be changed. For example, if you are in regular, you can see the regular is used for balanced feature availability and release stability. So whether you are having a new release for the GKE versions, or you are going to have the stability versions in your clusters. So regular is basically balance between them. And if you go to rapid, so it is basically it is for the new releases they have qualified for production use or general availability. Whereas in the extended, use it to stay on a minor versions for up to 24 months, and versions receive patch update until they reach the end of extended support. So GKE automatically upgrade the cluster, but you need to make sure that versions receive patch update until they reach the end of support extended period. So basically, this is how this release channel can be chosen for having your versions and stability to keep in your mind. So you can check any of the versions. So maybe the higher versions will have the higher features or more recent features, but the default and stable one is the good one that actually GKE recommends. So versions in the regular channel have been qualified over a longer period, and they offer a balanced features availability and release stability that whatever you have mentioned. Now, this is the cluster tier. Now, this cluster tier, we are having two options. One is standard tier, one is enterprise tier. Definitely, if you are having the production scale workloads and enterprise tier, definitely benefit for some additional features for governing and managing and operating containerized workloads at enterprise scale. Whereas a standard tier doesn't include that feature, but you can use the standard tier for containerized your application with scaling capability of GKE, which is great for use as well. And I know that many projects in the industry runs their workload on standard tier, even in very good MNCs as well. They recommend the standard tier. But when it comes on Google provided uh, governing features and security, then enterprise tier is highly recommended, because this is the standard industry practice to use the enterprise tier GKE cluster. So this is highly recommended for this enterprise tier to be created for your production workload for most of the industry. Now, you can't use this enterprise tier unless you enable your feature for the enterprise. So for now, I'm just fine with standard tier, but you can enable your standard, your enterprise tier for your Kubernetes cluster to be created. All right, so we have done the first topic over here, which is cluster basics. Now, the next one is fleet registration. Now, I'm not going to let you know in this particular lecture what exactly the fleet means, but let me introduce this fleet for now. So, if you are having a logical group of Kubernetes clusters, a fleet is basically laid to the logically grouping and normalize this Kubernetes cluster. And this cluster will be hosted in a particular project, and you need to register your cluster in that particular project to get your cluster registered in that fleet. So basically, this cluster registration inside the fleet will help you to part of this greater Kubernetes cluster. And there is a long story behind this use case, where you need to centralize your billing. So we are not going to cover all these stuff for this fleet for now, but fleet is a great logical grouping of your clusters, and you can have these flavors in your GKE environment. All right, so we are not going to do anything. We are not keeping this project as a fleet registered project, and we are not going to register our clusters in any fleet. So we are skipping this one. The next one is node pools. Okay, so when we go to these node pool details, what exactly the node pool, let me tell you. So node pools are the pool of nodes, or the cluster of nodes. Nodes are basically nothing but you can think it as the virtual machines, and these virtual machines are going to be clustered as a node inside a node pool. So if you are having one node pool, you can register a couple of virtual machines inside them. Those are having these Kubernetes installed, and they can communicate with themselves as a cluster inside the GKE environment. So node pool is nothing but a group of virtual machines, and the node pool is basically a template of those virtual machines, how they will be created and configured. So one GKE cluster can have multiple node pools, and similar kind of activities or workload can be put in a node pool basically. So you can physically and logically divide your workload in different node pools, and you can configure your node pools accordingly. So for now, I'm just going to name these node pool as default pool, whatever is given over there. Now, this is the control plane version that it is mentioning 1.30.5. And here you can have two options how you can place the nodes inside the node pools. So one is compact placement. Now, compact placement is basically if you are having the nodes, those are placed in the same availability domain to ensure the low communication latency. So if you are having three nodes inside a node pool, and these three nodes are in the same availability zone, then that will ensure that the communications between these nodes are very fast. So this is kind of a compact placement, and you need to ensure that you are having one location you have to choose when you are going to create this GKE cluster. All right, so the next one is queue provisioning with dynamic workload scheduler. So queue provisioning enables use of node pool with provisioning request API to queue for GPU capacity. So if you are having the requirement of having the GPU capacity and you need to queue your provisioning, then you can go for this one. But one point you need to make sure that once you enable these features, you cannot revert it back. So make sure that you really need these features. If you really need these fast performance, which is very much important rather than keeping your workload uh, for high availability, then go for compact placement. But if you think that your workload needs to be so robust, it should not go down for any zonal failure, then don't enable these compact placement, for example. So think it wisely and choose the options wisely. So next is how many number of machines will be there per zone. So we have selected 3 zones. So that's why if we are having uh, 1 nodes per zone, that means total we are having 9 zones. 3 multiplies by 3, which is 9. So each zone will have 1 node and total will have 9 nodes. If we keep it as 1, that means in each zone, 1 node will be created. So as we are having 3 zones, we have mentioned the 3 zones, US Central 1, A, B, and C. So the total 3 nodes will be created in these node pool. Now, if you want to have the cluster automatically scale, so you can select the cluster autoscaler. So this will automatically create or deletes nodes based on your workload needs. So if you having your workloads to scale automatically, and if in that case, if it reaches the limit, the size limit that we have put over there, then it will uh, automatically scale out the number of nodes in the node pool. So though we have mentioned 3, it can add 1 more in that node pool if this autoscaler thinks that we need to have 1 more node in that node pool due to the increased workload. So what can be the allocation policy for these autoscaler? It can be balanced or any. So if it is balanced, the autoscaler considers pod requirements and the availability of resource in each zone, but tries to spread the nodes equally among zones. So if it is balanced, then the autoscaler will try to have the nodes spread across zones. But if it is any, then it will take the random approach. But it will prioritize the utilization of unused reservations and to account for current resource availability constraints. If we have put this par zone limit, then it will basically enforce that given limits on per zone basis. So for example, we are having US Central 1, A, B, and C. So it will ensure that minimum number of nodes per zone should be maintained like this. So if I say 1, that means at least 1 node will be created per zone. So it will create 3. If I say 0, then that means there is no minimum requirements of nodes to be kept. And total limit, if we keep the total limit that it is not having per zone basis, but it will basically the node independently of that spreading on each node. So based on that, so if you are having your business requirement is having to spread across the zones to have the higher availability, then you can go with per zone limits. Otherwise, you can stick with total limits. Now you can specify locations. We already have these A, B, C mentioned before. So that's the default one, but you can definitely override this one over here in this node pool group. So for example, we can disable the C and we can enable F. So this particular node pool, all these things will be, all the nodes will be created at A, B, and F. Now this automation is automatically enabled. So this is automatically upgrade your nodes to the next available version. And it is also enabled for auto repair. So auto repair is required when using a release channel. Now, node pool upgrade strategy, we're having the search upgrade and fast and more cost effective for stable workloads and upgrades nodes one at a time in place. By default, a temporary additional node is created when upgrading each node. To reduce the cost with a greater risk of disruption, set the max search to 0 and max unavailable to 1. So this is how the node pool upgrade will be take will be taken into the place, whether it is a Sarge upgrade or it's a blue-green upgrade. So if it is a Sarge upgrade, then it will be a faster and more cost-effective. And this is basically most of the cases for the stable workloads. But blue-green approach is basically when you want to reduce the risk of workloads that are sensitive to disruption. Your pool will be having some nodes to be maintained for during the upgrade. So you need to specify the batch soak durations and node pool soak durations. So durations, a batch soak duration is the durations to wait after each batch finishes draining. So unless your batch is having in a completed state, has reached the completed state, this is not going to be washed out. It will be gradually drained, and then this is the duration that you need to uh, maintain during the upgradation. Similarly, node pool soak duration is the duration that is basically to wait when all the batches are completely drained. And this is the opportunity to verify your workload's health. Now, you need to specify these two things to wait for the nodes to be completely drained out. Sarge upgrade is something that is cost effectively, and we can specify the max surge and max unavailable. So, which will ensure that how much nodes will be unavailable during the upgrade. So that's all in this particular form for node pools. We can have the nodes. So what are the nodes that you are going to create inside the node pools? So you need to configure the details of these nodes as well. So this is where you are going to specify your machine type and machine details of each of the nodes that you are going to create inside the node pool. By default, the container optimized OS with container D, that is COS container. So this particular image type is automatically selected, but you can use the other ones like Ubuntu with container D or Windows or other OS type as well. But COS is the most useful one for the container running machines. For the machine type, definitely you can have GPU, TPU, compute optimized, memory optimized, or storage optimized devices, or the general purpose one. We are not going deep into that, each of these machine types, but for now, I'm just having these E2 standard or maybe E2 small or micro because we are not having so much workload going to be created inside the node pools. And you can have the balanced persistent disk. You can definitely change it to SSD performance persistent disk for having higher IO or the standard persistent disk for the most cost effectiveness. And the balanced one is between them. And you can keep the boot size, disk size as well. Maybe we can keep it as 20. So each of the machines will be created with 20 GB of disk, and those disks are balanced persistent disk only. You can specify the encryption policy, and this is the Google managed encryption key, or maybe if you are having one KMS key, then you can provide the KMS key as well. This is how the data will be encrypted inside the virtual machines in these clusters. Now, here is advanced options, which is basically using for ephemeral storage local SSDs and raw block local SSDs. Now, these are going to be chosen for your advanced level of IO, depending upon your business requirement. And if you are having your workload for the batch jobs or something like that, you can definitely use these spot instances for the workloads. And these spot VMs are the compute engine spot VMs, and these will be offered with 90% up to 90% of discounts. And these spot VMs will be created with there is no guarantee to maintain that spot VM's entire life cycle of this Kubernetes cluster. It can be taken into back to the Google spool in maybe next 24 hours or so, or maybe less than that, depending upon the demand of these spot VMs. Now, if you enable this one, however, Google Cloud Kubernetes engine will ensure to keep the number of nodes equal to the number that you have mentioned per zone basis, that is 3 in our case. So whether this VM is going to be died or taken away, GKE will ensure to create or spin up another VM inside this node pool to ensure that the availability of the nodes are maintained correctly inside the node pool. So it is highly recommended to use these spot VMs when you are having these batch workloads. Now, this is all about this node pool. We can go to networking, and here we need to provide the networking details for the node pools. Now, you can specify the maximum number of pods you are going to use per node, and that can take up to 24. So if I say 25, it can go up to 256. So maybe it can be minimum 8 and maximum 256. So we can specify anything between that. Maybe we can say 100. So maximum 100 pods per nodes will be created. And this is how the scheduler will schedule the pods in the nodes in the GKE cluster. If you are having any tags specifically for allowing or disallowing the traffic, you can definitely play around that with your network tags. And this is how we can create the secondary range of your CIDR pod secondary CIDR range, and this will be automatically created. You can keep this pod range any CIDR range, so that automatically it will be created and enable your Kubernetes engine to manage the secondary range used by this cluster. So you can manually as well manage these things as well. In the security section, you can see how you are going to keep the node secured, and that will be under your control. Definitely in the autopilot mode, you cannot configure all these details. You cannot specify the node pools and the automatic security and network configurations. You cannot even choose what kind of container, what kind of machines you are going to create inside the GKE platform. But definitely, as we are having in the standard mode, we can specify the security, network, nodes, machine type, etc., etc. So here the security comes into the picture. You can specify the service account, which can be used for your workload that is going to be run in the GKE platform. So by default, the compute engine default service account is being used, which is automatically created by Google. which is having some kind of access, and this is the service account which is basically used when you create the compute instances inside the Google Cloud platform. And this computing in default service account was not created manually, rather it was created by Google by default. Now, the next which is comes into the picture, which is access scope. Now you can provide the access of all your cloud APIs. If you want the internal communications needs to be applied, so we can specify the internal Google Cloud APIs can have. This GKE cluster can have access, specifically this node pool. Uh, this basically you can see during creation of the virtual machine inside the GCP platform as well. So this is nothing new. So as we are specifying the VM instances, the networking part and the machine type part are exactly same as we see in the VM instance creation parts. So you can use the full access to all cloud APIs, or you can specify each API, which API this node pool can use. All right. So next one is shielded option. If you have the enable secure boot, then your secure boots will protect your nodes against boot level and kernel level malware and rootkits. And this integrity monitoring will help you to monitor and verify the runtime boot integrity of your shielded nodes using cloud monitoring. So it's better to have them checked, because those are the Google's how Google actually ensuring against the threat attacks. So the next one is the confidential GKE node. So what exactly the confidential GKE node? Whenever the processing is made on the memory level, it normally plays with the unencrypted data. But when you use the confidential GKE node, then all the data inside the memory of these servers will be kept encrypted as well. So this is what in the security field. And next is metadata, where you can keep your GKE clusters, some tags and labels, and those you can use for your business metadata keeping purpose. And this is very important, but for now I'm not giving any metadata as of now. Now this automation is basically how you are going to automate everything. For example, the maintenance window, how you are going to keep your maintenance policy. So if you enable, then you need to provide the editor like weekly editor or custom editor, and you need to specify the time when you want to have this maintenance to be done. Next is notification, whether you are going to enable notification so that it can communicate with this pops up, and the pops up can control the Kubernetes engine, and it can notify the Kubernetes engine if you have any notifications to be sent from the pops up to integrate this with GKE. Now, if you want to vertical pod auto scaling, then you can keep this automatic vertical pod auto scaling. That lets you to configure the vertical pod auto scaler object for the cluster's workload. And this vertical pod auto scaling will analyze and adjust your container's CPU requests and memory requests based on the actual resource consumption of your workload, so that if there is any request comes into having the higher memory or CPU, GKE will provision those things unless it is not available inside this node. So GKE will help the pod to scale vertically if the request comes in to the workload. This particular option enable node auto provisioning. So it will create and delete the entire node pool as needed. So whenever there is any requirement comes to the picture to create an entire node pool for you, so it will create the node pool based upon your workloads. What is the basically limit of creating these node pools? Definitely, you can specify the number of minimum CPU and maximum CPU and memory for your provisioning of these resources or nodes inside the node pool. So all nodes are used to compute the total cluster resources, including the nodes in non-auto-scaling node pools. And you can specify the service account, like which service account will be used to create those node pools. So you can specify exactly the same way we configured inside the default node pool that we configured on last form. For example, let me show you. Here actually we use the same thing for a default node pool, but it's a cluster level thing. So we are going to specify whether we are having these default access or we have the full access of all cloud APIs or not. Similarly, we are going to keep this thing. And similarly, we are having these checkboxes automatically upgrade the next available version, enable auto repair, surge upgrade, exactly the same thing that we did inside the default node pool. As we are specifying these things, because we have clicked the enabled automatic node pool creation. So we need to specify in which particular zone these nodes pool will be created and distributed the nodes. And we need to specify the tags as well. So as per this configuration, it will automatically create the node pool for you. All right. So this is all about the automation. The networking is the same, like we can keep our control plane access. We can configure the DNS. So DNS-based control plane access is recommended, but you can I mean, by default, it is not enabled and it is going to use the IP-based control plane access. But DNS is recommended because it will help to secure your communication in that way. And if you keep this DNS, it is optional. You can use the IPv4 address communication or not. But it is recommended to have this DNS one only, not this one. But if you enable these access IPv4 access communication, then it's recommended to enable the authorized network only. So unless it is not authorized, then IP communications within this cluster is not allowed. But I mean, you can definitely keep it visible, but it is recommended to have it one over there. All right, so this is all about the authorized network, but you need to specify which particular network you need to authorize. So if you provide the CIDR range inside your cluster, all these communication will be made between inside them. All right, so this is our cluster networking. We don't have any other VPCs other than default one, so I'm just going to keep the default. But it is recommended to have to create one VPC for your entire cluster or the node pools, and you can use that network for your cluster communications. All right, so again, I mean, we are having these things, enable private nodes. Now, this is the nodes, those are having only internal IP address. It will not have any external IP address. So, all the communications will be done inside the cluster through internal IP only. And you can't access these virtual machines outside of these GKE cluster. Now, you are having some advanced networking options, like if you are having, if you want to override your control plane's default private endpoint subnet, then you can provide the subnet access point where your control plane will actually use which private subnet. So enable VPC native traffic routing. So VPC native traffic routing uses an alias IP address range and provides a more secure integration with Google Cloud services. Now, again, this is basically a permanent choice. You need to wisely make the decision, like whether you want to enable the VPC native traffic routing, but it is always recommended to have these VPC native traffic routing only. You can disable the default SNAT used for IP mask coding, and this is a form of source network address translation or SNAT that performs many-to-one IP address translation. All right, so these are very high level concepts for the networking. I'm not going to go deep inside them. And you can, having your cluster IP, cluster default port address range, you can provide the CIDR range as well accordingly. You can specify the maximum ports per node and the service account range, and you can have those options enabled as well. Now you can enable data plane V2, Kubernetes network policy also enabled. So if you have this enabled, then you need to choose the V2 metrics and observability too. And this actually brings a greater network security, visibility, and scalability with GKE using the power of eBPF. And this is the recommended options, and you will have the enabled in the future release, but for now you have the options to keep them disabled as well. If you enable this one, automatically it plays out. It plays out because either you can choose the data plane function v2, or you can use the Calico or FQDN network policy or internode transfer encryption policy. So accordingly, you can choose. And this is the intra-node visibility. So this reveals your intra-node traffic to Google's networking fabric. And to get logs, you need to enable these VPC log flows as well. So if your logs are enabled, then you can enable the intra-node visibility to check the how the network flows inside the VPCs. You can enable the HTTP load balancing, and HTTP load balancing is the additional add-on feature. So whenever you are going to use the load balancer type of services, you can use this HTTP load balancer. So it will take the benefit of GCP's internal load balancer whenever you are having a service which is a type of load balancer. Otherwise, if you don't use this one, then you can't use the load balancer type of services. You will only have to use the node port or cluster IP. So you definitely check this one for your workloads. And this is the subsetting of L4 internal load balancer. So if you want to enable that one, you can definitely enable this. And Gateway API. So Gateway API is the open source standard for the service networking. If you want to have this API to be enabled, you have to check this during the creation of these clusters. And DNS provider can be Cube DNS or Cloud DNS. Cube DNS is an open source one, and the Cloud DNS is basically the Google Cloud one. So it can be Cube DNS or Cloud DNS. If you choose the Cloud DNS, definitely you can use Google Cloud's DNS services. And node local and DNS cache is basically for the DNS caching agent on the cluster node, as the daemon said. So if you want to enable these cache, then you can have these node local and DNS cache enabled in this cluster. So this is all about the networking, and the security is similar like what we defined in the node pool. So exactly same, not going to repeat once again. So you are having all these things over there like secret manager, shield, GKE, and application layer secrets, workload identity, and Google group for RBAC. So this is basically Um, all the members of this Google Workspace group will help you to grant the roles of role level access policy. And if you enable this workload identity, that will help you to connect securely to the Google APIs from the Kubernetes engine workload. If you don't enable that, basically it is automatically enabled by the future releases, but you have the options to disable it one. But it is always recommended to enable this one, and you need to specify the workload pool where you want to have this workload to be connected to securely by Google APIs. And you can have this vulnerability scanning on, so you can check your workload is vulnerable or not through this scanning. And vulnerability scanning pod is each node in the cluster for this scanning, and you can have basic for the container OS. And if you are having the language pack and container OS, then you can have the advanced version. So it can be either advanced or basic. For Windows workload OS vulnerability scanning, you require the versions 1.3 or higher. We are using 1.30, so definitely we can use the basic one. All right, so the legacy security options are to support in-cluster permissions for existing clusters or workflows, and this prevents the full RBAC support anyway. And issue a client certificate to maximize the security, and you cannot change the settings once you have created. So make a wise decision before you are going to issue a client certificate. And this is our backup plan. So you can enable the backup of GKE. So backup and restore GKE workload, and the size of data and the number of pods you protect to backups. And you can create the backup plan as well, and you can give some name and region where your backup will be uh, created and retained for another 7 days. And you can definitely edit this plan, and you can make a smart choice, like whether it can be a cron schedule or you are having a target RPO based schedule to define the retention and backup schedule. So this is very straightforward. You can provide the region where your backup will be stored. You can say like between 1 hour to 60 days. You can uh, you can try to schedule your backup, right? Every 1 day we are going to take the backup, and you can define frequency and the time when your backup can be started, and how much duration you need to put, like 2 hours, 2 days, or something like that, 2 hours, 2 minutes, or seconds. And this particular window will be defined to have those backups to be created. And you can specify some dates, like maybe during the peak holiday periods when your sales are higher, you can exclude the backups, because if we start to have the backup, then probably it can affect your performance. So you can definitely have some exclusion dates as well to define. So on those dates, backups will not be taken. Retention period is the period until which the backups will be kept inside this Google Cloud platform. And you are having the details options, like whether you want to take the backup for the entire cluster or some namespace, or within some applications inside the cluster. So you can specify how you're going to take the backups. And the backups can be uh, taken with permissive mode. So if we completely successfully, the Kubernetes resource that potentially caused restore failure and are detected during the backup process. And you can either choose it or not, depending upon your business use case. But you can definitely need to provide like what are the things you need to include in the backups, like secrets or persistent volume data. So all these things will be automatically backed up along with your data. And you can, at the last but not the least, you can provide the encryption key, how you're going to encrypt your backup. So all these things you need to provide through the backup policy, and this will be defined, and this is how you can take the backup. So you can either choose it or you can disable it depending upon your business use case, but backup plan should be there for any production scale Kubernetes cluster workload. This is the metadata. You can keep the key level key value pairs for your for tagging your GKE cluster, and the features is basically the features that you want to have for your GKE. For example, the logging. You can specify how you will go to have the logging for your GKE cluster, whether it is system, API servers, scheduler, control manager, control plane, or the worker nodes. So all these logs will be logged into the cloud logs, and how you are going to enable cloud monitoring, whether you need to have this cloud monitoring or not, and if it is enabled, then what are the things will be captured, like pods, deployment, statefulness, all these pod related stuff. If you are having GPUs, the API servers, scheduler, control manager. So all these things you need to mention, like if you have this cloud monitoring on, and you can have this managed service from Prometheus to be enabled, so that you can use the Prometheus to have your cluster monitoring more useful, and you can enable the automatic application on monitoring. So it will automatically collect metrics using managed services for Prometheus, and out of the box dashboard will be provided. You can check this match service, and this will help you to register your cluster to a fleet and enable the mesh service for any cluster that is added to that fleet. And as we did not register this cluster to any fleet, it is not enabled right now. We can have these ray operators to be enabled for AI and machine learning. And ray is a distributed framework for AI and Python. And this feature enables Kubernetes APIs for managing and scaling ray clusters and jobs. You control and are responsible for managing ray.io custom resources in your clusters. This feature is not compatible with GKE clusters that already have another ray operator installed. Supports clusters on Kubernetes version 1.29.8, and we are having more than that, so we can use these features as well. You can have your cloud TPU, and you can enable the Kubernetes features for cost allocations, for backup, computing in persistent CSI driver, uh, and as well as file store CSI drivers. So all these drivers you can have on for your clusters to have those features. Even you can use these Fuse CSI driver as well if you want to use the cloud storage as a permanent disk, or it's not a permanent disk, but you can use this Google Cloud as a driver or the file system for your internal pods. So they can store some data in the cloud store directly through Fuse. You can have enable image streaming. So this will allow the workloads to initialize without waiting for entire image to download. So you can definitely use this image streaming. Uh, you can have enable config connector that will allow to manage your Google Cloud resources to Kubernetes configurations. And you can have these GKE usage metering as well. So this will help you to see your cluster's resource uses. And you can check it. That can be sliced down by Kubernetes namespace, labels, attributes, etc., etc. So you can use this metering as well. So all these things are comes into the feature. So we are done with all these options, and now we are ready to create the cluster. We can click this create button to have this cluster created. Now, while this cluster is being created, let us quickly jump into the compute engine dashboard, and we can see that right now there is no compute engine registered inside this platform. Let me refresh this. So we don't have any compute engine right now, but once our cluster is being created, so our cluster is being created, we can click this one and we can see the progress. So we have 30% done for this configuration. So it is right now in the deploying phase. So right now, the VM machines that we have configured inside this uh, form, right now it is being checked and it is using these forms to create the VM instances for us. So if we refresh this page, uh, very soon we will see some VMs will be created as per our configuration. So you can see that three VMs are being created because we said that one VM we need for each of the zones. So you can see A, B, C zones are chosen for creating three VMs, and you can see my GKE cluster GKE is the name of those VMs. So right now these VMs are being created, and then it will create you the Kubernetes, kubeadm, CTL, admins, all these things will be created inside these VMs. And once it is done, you will see these deploying will be completed. Right now, it just created these VMs. The VMs are running. Now it is configuring these VMs for installing these Kubernetes and set up the Kubernetes as per our configuration. So let's wait for some time. This is 60. Now this deployment is completed. Now the health checks is being done. We can see the VMs are ready. So the next, once these health checks will be done, we will come back and we will try to connect to these uh, cluster, and we'll see how these clusters are behaving. All right, so our cluster has been created. Now we can see this is the cluster basics. We are having the control plane installed on US Central 1A, and our default node zones are A, B, C. And we are having pretty much everything that we have configured. So let's try to connect to this instance, connect to this GKE cluster. So for that, we need to click this connect button, and we can get one command how we can actually interact with this GKE cluster. So let us copy this one. Let me go back to the screen and enable this cloud shell. So we can go for continue. We can go to this new window. Let's wait for some time for this cloud shell to be initialized. Instance right now. All right, so we have connected to this instance, and maybe we can use the command kubectl get nodes minus wide, and we can see the nodes are there inside these clusters. So we can see our three nodes are accessible to these clusters, and these are the internal IP address and external IP address, and these are the ways that we have chosen for these nodes. we can see there is no pods right now. So we don't have any pods. Maybe we can just deploy one pod over there and we can see how these can be accessed. What we will do, we will simply run the Nginx service from our Docker image, and we will see whether we can use this cluster to run our first Nginx service. So for that, what we will do, we will just say Kubernetes kubectl run nginx minus minus image docker io, and we can say nginx. So what it will do, it will create the nginx uh, for us. So if we say get pods minus o wide, we can see the nginx is running. Now, if we say kubectl get service, definitely we don't have any service, but let us see what are the services are there. So it is a internal Kubernetes service, which is cluster IP is created. Now we can say, all right, so now let's see what other things are there inside this kubectl. We can say kubectl get all. We can see the pods. One of the pods is named Nginx is there, and the default service has been created, which is a cluster IP. We can definitely uh, expose this pod. So we can say kubectl expose pod, and we can say this as type load balancer. And we can mention port number 80. So what it will do, it will expose this pod as a load balancer type of service. So we can say kubectl get service minus o y to see the exact IP address of this load balancer, and it is in pending state. Maybe we can keep an I over there by specifying -1, and we can see it's still pending. In a minute or so, it will be having one external IP address. So let's wait for some time. Yeah, we are having this external IP. So we can copy this external IP and go to this external IP address. We should see this Nginx is running. You can see this Nginx is running. So that's it for today. So we can how we have created these GKE cluster inside these GCP platform, and we have successfully run our Nginx application in this particular Kubernetes cluster inside the GCP. So in the upcoming lectures, we will go deep into these Kubernetes to explore more on the monitoring things. We can try to install the Prometheus, and we can try to install these Grafana to monitor these Kubernetes from our from the web-based tool. Thanks for watching this video. I think it will be helpful for you if you are going to use this marvelous GKE for your production scale workload. If you have any questions, you can definitely let us know through comments. We'll be back to you as soon as we get those. Uh, Thanks for watching once again, and see you in the next lecture. Till then, take care. Goodbye.